Guys, welcome back to Chemicals TV, and in this video we are going to talk about percentage yield calculation. Now this is actually a continuation of our previous video on limited reactant and reactant in excess. I've done videos on that. Now before you can start solving questions on percentage yield, you must understand what is limited reactant, what is reactant in excess, and how can you calculate the amount of product produced during the course of a chemical reaction. Not only that, you must also know how to calculate the amount left in the reaction you get. So I will leave a link at the description below so that you can go check those video out, because now before you can start solving the question here, you need to understand that doing that. But in this video, now let's focus our attention on what percentage yield. First of all, you may ask yourself, what is percentage yield? Percentage yield is what is the percentage of the amount of the product produced when the reaction stops. So the percentage of the percentage of the amount of the product you get when the reaction starts, called the percentage of yield. Now, how can you calculate what percentage yield? There are two things you must put in mind. You must know what the actual yield and what theoretical yield of that product. So now, what is the actual yield? Actual yield is the actual amount of the product you get. Is the actual amount of the product you get in that reaction. Then theoretical yield is the expected amount, or is the maximum amount of the product you are going to get when all the limited reactant are converted to product. Now we understand that when the chemical reaction takes place, not all the limited reactant will be converted. Do you get that? So theoretical yield is the maximum amount of the product you get when all the amount of the product are when all the amount of the limited reactant are converted to product. Do you get that? So now when solving percentage yield question, there are some things you must take note of or look at in that question. First of all, mass of the product will be given to you, and mass of the limited reactant will be given to you. Now, what you want to understand is that the mass of the product given to you in that question is what your actual yield. So, you say that when the question is given to you and there's a mass of a product in that question, that is the actual yield of that product. Then the mass of the limited reactant that will be given to you, use to calculate the mass of the product. That will be what theoretical yield you get. So now let me give you some questions. Now let's solve some questions, or take some questions, so I can actually understand what I'm trying to say here, right? So now let's look at what this question here. So it says what is the percentage of 112 SO2 is obtained from the combustion of 78.1 milligram of carbon disulfide according to the reaction. Now here they ask me now what is the percentage of SO2 that is obtained. Do you get that? Now when you look at the question here, now they're giving us mass of SO2 here, right? So now this mass of SO2 given to me, like what I told you, is actually the actual yield of this SO2 that is produced. Do you get that? So here you want to say mass of SO2, which is the actual yield, is equal to 112 milligram. Do you get that? Now you have to convert milligram to gram by divide by 1000. So if you divide by 1000, here I'm going to have 0.112 gram. You get, so this milligram you have to convert to gram. You get. Now obtain for the combustion of 78.1 milligram of carbon disulfide. So now we have been given mass of this guy here. You get, so mass of the carbon disulfide. You get that? Now if you have carbon disulfide is the limit to reactant. You get, so it's given to me to be 78.1 milligram. Of course I'm going to divide by 1000. And when you divide by 1000, here I'm going to have 0.078 1 gram. You get. So now what you want to do here, remember you have to calculate your percentage yield. Therefore you have to know your actual yield, which we are already giving. They have to calculate what the theoretical yield of the product you get. So theoretical yield, which was mass of SO2, again you have to calculate, it's called the theoretical yield. We don't know it, right? And they say we will calculate the percentage yield. So that is afterwards use the mass of this one here to calculate the mass of this other one here. You get. And if you have been following my video on reacting masses, now we have different approaches or in what solving this question here. But now the approach I'm going to show to you is very easy and is straight to the point. You get. So now let's use the mass of this one here to calculate what mass of this one here. So the mass of this one I want to calculate, the mass of what SO2 I want to calculate. Now I'm not going to do what my theoretical what theory. You get. So how do we do that? Follow what a simple method here which I'm going to show you here. In order to calculate the mass of this guy here, it's very easy. What we want to do here is to what? Write the word balanced chemical equation of the reaction which we have already given here. So what we want to do here is to what? Know the mole and the mass. Is okay. Now our focal point is going to be this guy and this guy. Yeah, so the rest this other two is not actually what important. So we have to look for the mole of this guy, then the mass of this guy, and the mass of this guy. So if you have followed my video, you find that the mole of this guy here we have what 1 mole. It's called the balance mole, right? One mole of this one here is what 2 mole. So how do you get what the mass? The mass, you get the mass for the molar mass of this guy here. So here we have, if you calculate the molar mass of what carbon disulfide, which what CX2, go to what carbon, the atomic mass of carbon is what is 12. So going to be 12 times 1. You get plus what? The atomic mass of sulfur is what 32. Going to be what? 32 times 2. Right? So 12 times 1 is what 12 plus 64. 64. Do that. So when you add them together, 12 plus 64, here we have 76 grams per mole. You get. So what do you mean? It means that for every 1 mole of carbon disulfide, you have what 76 gram. So for 1 mole of what carbon disulfide CX2, I have what 76 grams of what carbon disulfide, right? So how many moles do you have here? Here we have 1 mole. So 1 times 76, here I have what 76 gram. You get. The next thing is what SO2, which is 32 times 1, right? Plus what 16 times 2. Here we have what 32 plus 32, right? So 32 plus 32, here we have 64 grams per mole. You get 64 grams per mole. So it means that for every 1 mole of what SO2, I have what 64 grams of what SO2. You get. So how many moles do we have here? Here we have 2 moles. So 2 times 64. 2 times what 64. Here I have what 128 gram. 8 gram. You get. So this is the first thing you want to do in order to calculate what mass of the stuff here. Remember, now we actually want to look for what mass of this guy here, right? So we're going to do what mass of what SO2 equals to. Now we are being given mass of this one in the question here, which is this one here, carbon disulfide here. The mass given to me is what 0.07781 gram. Remember, it was given to me in milligram. I have to convert to gram, right? So now I'm going to do what 0.0781 gram of what CX2 over what 1 times. Now the mass of this one I'm actually calculating now. Come to the front, come to the top. 128 gram of what SO2. For the balance mass here we have what 128 gram of what SO2. You go to the top. Why this one CS2, which carbon disulfide, you have go to the down. Here we have what 76 gram of what CX2. You get. Now so that this one we cancel out this guy here. You get. So what will happen here? This times this divided by this 0.0781 times 128 divided by 76. So here we have 0.1315 gram. So now this mass I've actually calculated is now going to be what my theoretical heat of what SO2, right? So mass of this one calculated, mass of SO2 calculated, going to be a theoretical what heat, theoretical heat is what 0.1315 what gram. You get, yeah, my actual yield is already given to me, right? So our actual yield, okay, mass given, here we have mass of SO2 given, we want actual yield equals to what 0.1112 what gram. You get. So now with this one here, we can now calculate what my percentage is. Now another thing I want to put in mind is that now my theoretical heat is always higher than what my actual heat. Do you get that? Then what this one you always put in mind. Theoretical heat is always higher than what actual heat. So if you now apply the formula here, percentage heat, here we have percentage heat now of the product equals to what the actual heat over what theoretical heat times 100 over what 1. So if now you what you have to do here is what impute your value. Actual heat is what 0.1112 what gram over what theoretical heat is what 0.1315 what gram times what 100 over what 1. So what you want to do is what punch your calculator and get you what your answer 0.112 times 100 divided by 0.1315. Then we have what 85. So it's going to be what 85.17%. So this is what my actual what yield. You get. So these are to what to solve it here. I'm going to give you now. Let's solve one question that you might likely see in your what in your exam. Another form of question that comes under what percentage. And the second question. Now these are type of question you will see in your what in your exam. Now look at it here. Start. The percentage yield for the what reaction. Look at the reaction here is 83.2%. What parts of what phosphorus pentachloride is expected from the reaction of 73.0 gram of what PCl3 with excess chlorine. Now if you look at the reaction here, PCl3 is what is the limiting reactant. Why is what is the reactant in what excess? Now the percentage is given to you. So first you want to write out here data given. It's okay. Data given is what percentage yield of what of the product, which was PCl5 is given to me as what 83.2%. Now they're asking what mass of PCl3 is expected from the reaction of this here. So in saying that, what they actually want to look for is what is the actual heat. You get. Now because that is the stuff you expect. You get. So my actual heat now, that's what you are looking for. Do you get that? And the mass of what the limiting reactant is being given to me. So mass of PCl3 is given to me as what 73.0 gram. Now how do I know if it's my actual heat I'm looking for? Because that may be the question that is in your mind. Look at something here. The mass of the limiting reactant is only used to calculate what the theoretical heat of the product. You get. So if they're asking what is the mass expected, they actually ask you to what to calculate what the actual heat. Now, so what are you going to use this mass to do? Right? So remember, percentage equals to what? Our actual heat over what? Theoretical what heat. times what 100 over what 1, right? 100 over what 1. So actual yield over theoretical yield times 100 over 1. Remember, how do you get your theoretical yield? You always use your limiting reactant to get what your theoretical what yield. Now, what is theoretical yield? Remember, I told you that theoretical yield is the maximum amount of the product that will produce when all the limiting reactant be what converted to what to product. You get, assuming that all these will be used. What is the theoretical yield? You get that. So the product says you want calculate what the one you expect. You get. So for this one here, you are actually going to use this mass of what phosphorus trichloride to calculate what the maximum amount of the product you are supposed to get. You get. So you are going to use one here to calculate what mass of what of the limiting what of the what product here. You get. So follow the same pattern I've taught you or we have used in what in the first. Now follow the same pattern we have used in what first question. You want to use this one here to calculate mass of what of the product. You get. So what you want to do is to write balance chemical equation PCl3 plus what Cl2 give you what PCl5. You get. So you have to get what the mole and what mass, right? Remember, you're looking for this guy and this guy here. So how many moles do we have here? Here we have 1 mole. Here we have what 1 mole. Here we have what how do you get the mass? To calculate what the molar mass of this one here. Calculate what molar mass of this one here, right? Remember, the atomic mass of phosphorus is what 31 and chlorine is what 35 or what 5. So here we have molar mass of what PCl3 go to be what 31 times 1, right? Plus what 35.5 times what 3 137.5 gram per mole. What does it mean? That for every 1 mole of what PCl3 you have what 137.5 gram of what PCl3. So how many moles do you have here? Here we have 1 times 137.5. Here we have 137.5 gram. Same thing with this one here. Molar mass of what PCl5. Here we have 31 times 1 plus what? Here we have 35.5 times 5. So 148.5. So here you go to be what? 148.5 gram. So remember, the mass of this one was given to me, right? So mass of PCl3 is given to me as what 73.0 gram, right? Now I want to get the mass of this guy here. Mass of what PCl5. So how do you do that? It's very easy here. Here we have mass of what PCl5 equals to what? Now here we have 73.0 gram of what PCl3 or what 1, right? Times. Now because I'm looking for this guy, this will go to the top. Here we have 148.5 gram of what PCl5, right? Then this will go to the down. Here we have what 137.5 gram of what PCl3. Do you know why? So this guy we cancel what this guy here. So what I have to do now is to punch my calculator. 78 what 84 gram. Do you get that? So this is now what my theoretical what yield, right? This is now what my theoretical what yield. So yeah, now let me just write it up because I see easy to solve here. Now my actual yield, my percentage yield now. Percentage is what 83.2%, right? Now my theoretical yield now. My theoretical yield that I've already calculated now is going to be what 78.84 gram. So what I'm actually calculating is what is the actual yield. Actual yield. And what I'm actually want to calculate now, right? So if I should apply a formula, percentage yield equals to what? Actual yield. So percentage what? 80 what? 3.2 equals to. Now my actual yield is what? Do what I'm looking for. Actual yield. Actual yield over what? My theoretical is what? 78 the what? 84 gram times what? 100 over what? 1. You get? So if I should mention the same formula here, actual yield here, this time is divided by what? 100, right? So my actual yield now, actual yield is equal to what? 83.2 times 78.844 gram over what? 100. So now let's watch our calculator and get our answer. It's we have my actual yield. Actual yield now is equal to what? 65 dot what? 60 gram. Do you get that? Do what they actually want us to look for. You get? Remember I told you that. Now, we want you to know that if your answer is correct, is that your theoretical yield is always higher than what my actual yield. Do you get that? Yeah, here's what my actual yield. Here's what my theoretical what yield. You get? So theoretical yield is higher than what actual yield. So that shows that what you have done is what accurate. You get? So if you find this video helpful, please give it a like and subscribe to this channel if you have not done that. You get that? See you in the next video. Thanks for watching.